Hello and welcome back to my channel Mathematics Applied. Here I am with the third part of application of integrals. What I have done is I have broken this third part into two parts, that is 3a and 3b. Okay, why? Because it is getting little longer. If I do one part, I have to solve problems and then I have to tell you the basic concept also. It is taking a little longer than 30 minutes. So therefore I have broken this. So what exactly I am going to do in this part, third part, that is the A part. We had received from some functions, all the straight lines, all the objects, forms. We had y equals fx and x equals gy. We are going to integrate this and see what is the output like. What are we going to get out of that? If you know this, you master this, and then solving problems is not a trouble for you. So our target is 4 marks. Please remember that. So then we quickly go and take this straight lines. This is what we are going to do. Integration of functions received in part 2. So straight lines functions that we had, only 4 relations we had. So I am going to integrate this. Already done that. So here this is integral of y, because y is a function of x. So I will integrate with respect to x. So y dx, that gives me ax, right? Likewise, if you integrate x with respect to y, then you will get ay. So similarly, here also integral of y dx. What am I going to get? You will integrate this. So minus a by b into x square by 2. This is what you will get for this, and minus c by b, and you will get a x here. Similarly, for this one, integral x dy will give you minus b by a y square by 2, right? Minus c by a. What I am doing is only the constants I am repeating, and the y part, and here there is no y, so therefore there will be one y that will be coming because there is dy. So this is the output here. This is the output and this is the output. Now basically, which integral we have used in all these cases? In the straight lines case, only one formula, that is integral of x power n dx, which is we know x power n plus 1 by n plus 1. This is the only relation that we have used. Okay, I am not taking the constant, because as far as application of integrals is concerned, the constant has no role over here. So therefore we are not taking that constant. Okay, let's quickly go into the next, that is circles. In circle, we had only two forms, that is because circle has equation x square plus y square equal to a square. This is the only equation that we have for a circle, and this we have converted as y equals fx and x equals gy. So we have to now know what is the integration of this. So if you integrate y with respect to x, because this is a function of x, integral of root over a square minus x square dx. This gives you, if you just refer your NCERT book, and you will know that this is equal to x by 2 root over a square minus x square plus a square by 2 sine inverse x by a. This is the result for this one. Similarly, for this one, it is going to be, when you integrate this with respect to y, you will do that. So integral root over a square minus y square dy you will write. Here you have written dx, you will write dy, and this is going to give you y by 2 root over a square minus y square plus a square by 2 sine inverse y by a. So this is another result that we have for circle. This is the integration, right? Remember that I am doing integration of functions. So all that I received in part 2, I am going to integrate all that. And I should have a pattern, I should see a pattern, and that pattern makes my mind remember what I have, how do I have integrate? I have to integrate. In application of integrals, it's not so much complicated. So that's what I have to ensure. So for ellipse, we had this situation, right? This situation came because we had two equations for that. X square by a square plus y square by b square equal to 1. For this, we will have these formations. This is these ellipse. These two are the same ellipse, right? As we discussed in part 2. And then x square by b square plus y square by a square is equal to 1. This is the other one. For that, these are the formations. Now you integrate this integral y dx, right? So when we integrate this portion, we get b by a is a constant. Let us take it out. Now what remains is the same that is for circle. That's why I have taken it in the sequence. After circle, I have taken ellipse, not the parabola. So root over a square minus x square, that gives me x by 2 root over a square minus x square plus a square by 2 sine inverse x by a. This is the result for this integration. Now see, there is no much difference between the circle and the ellipse. Obviously there is difference between the equations, but you know, when you integrate, that is b by a is the only thing that is coming out, and rest of the thing is same for that circle. X square plus y square equals a square. Similarly, we get the following. For x equals a by b root over b square minus y square x dy, this is what you will do, and you get the result. See, all this have a pattern. Here it is a by b, and root b square minus y square, it is b square minus x square, a by b. So accordingly, so you can easily remember, this is, you know, there is only one formula that is required, and that is integral of root over a square minus x square. This is the relation you have to remember. Now that we have written all these places. So if you know this, this is another formula that you need to remember. So there is x power n and there is root over a square minus x square. These are the only two formulas that till now we require, okay? Not more than this in application of integrals. In case of parabola, we had these formations. So let's see what their integrations are. Now this is for the parabola that is open on the right side. So y square equals 4ax, this was the equation, and here this part is for x square equals 4ay, right? These are the two formations for this. So when we integrate this integral of y dx, it's a function of x. So again, x power n formula only we are applying here. So this is a constant, so 2 root a comes out. Integration of x power half is equal to x power 3 by 2 divided by 3 by 2. So that gives me, this 2 goes up, and that gives me 4 root a by 3 x power 3 by 2. This is the result. Similarly, because this is same as this, you know, only the xy is interchanged. So therefore now here the integral of x dy is going to give me the same result, but with x replaced with y. So here this result is going to be 4 by 3 root a, 4 by 3 root a into y power 3 by 2. This is the integral of x dy. Here this integral is going to give me integral of x dy is going to give me 1 by 4a, that is constant, comes out, y cube, again I am using the same formula, y power n, so y power 2, this is y power 3 by 3, so ultimately that is y cube by 12a. This is the result. Similarly for this one, integral x dy, y dx is going to give me x cube by 12a. This is the result, right? All these are results for parabola. Now let us come to the basic concept. This is the core of application of integrals. Now what is the concept? We have to see that every curve has got an equation, and that equation will be given to us. This is the equation that is given to us: y equals fx, x equals gy. Actually the equation is not given to us this way. We had created this. Now after you create, you understand that this represents the same curve. So let's say y equals fx represents this curve, and this is the curve for this equation also. So if you now try to integrate this, what is integration? You had integrated this, integrated y, integrated x. So what is that integration? When you do when you integrate y with respect to x, what do you get? You get some function f of x. Let's say some function f of x you will get. This is indefinite integral. Obviously you are getting a function, right? So this function will refer to another curve, obviously, but here we are talking about application of integrals. You are integrating, of course, but what is that we are going to achieve in this, right? Let us now limit this from a to b. We will integrate, but we will limit that integration from a to b. If we do not limit, that is a indefinite integral. If we limit, that becomes a definite integral. So therefore this becomes from a to b, which is exactly f of b minus f of a. This is what we get, right? And what is this? This is a value. This is what is very important for us. That is the concept here. We get a value. Now what does this value represent? Okay, now when you integrate, what you do is exactly, let's say at this point, this is a, and let us say this is the b point. Now you integrate this, that means you have a small strip you take. I have written y dx. So this strip, this strip is going to be of length y. This is going to be of length y because it's on the y direction. This strip is long. How much long it is? This is y distance long, because this is going to vary. This y starts from this particular point. This is of this length, and this goes on increasing, and this comes to this length, right? So somewhere in between, you can think of this as, because it is varying, therefore you can understand this as y, right? And what is that small length on the x direction that you have taken is dx. So you are, that is, if you see this is a small, it's a rectangle, right? When you see this rectangle, what is the area of this rectangle? Area is y times dx. This is what exactly we are doing here. You are multiplying y with dx, and you get the small strips area. So when you now take this strips, from a to b, this kind of strips from a to b, you go on taking so many strips. There will be so many strips coming out inside this, right? So from a to b, we are integrating this strip. That means from here to here, you are getting this whole region's area. You will be getting the area of this region when you integrate this. So this value is actually the area of this region. So this is actually an area of a region, right? Now this region is bounded. You see, it is bounded. This side, this side, this side, and the curve on one side. So in order to find the area of this region, what I have to do is, I should integrate this curve, integrate this curve with respect to x. If I am integrating it with respect to x, I do that this way, y dx, integral a to b. So I get this. Whatever result I get, that result is the area of this region bounded by x-axis. It's not below this. Understand this. Now if I want to find the, let us take the other side. If I want to find the area, bounded by the y-axis. This is the y-axis and this is the curve, and here it is bounded from C to D, it is going. Okay, so if I want the region area, this region's area, if I want, what I will do is I take a small strip here, and this strip will be of length x, right? It is starting from this point, it is continuously varying, so this length will be x, and the small distance you are taking this side is y. So you will integrate x with respect to y from C to D. This is what you will get as a value, and that value is going to represent the area for this. You got this? This is the concept, right? Now this curve can keep on varying. This curve is, as you have seen, there are some objects, line, then a circle, parabola, you have ellipse, right? All these objects are going to have some curve, right? If you are, for example, I will tell you, for example, if you are asked to find the area inside a circle, if you are asked to find the area inside a circle, what you do is you logically construct a circle like this, and we know only this type of circle is going to be the content of this chapter, right? Center is always at 0, 0. So if you can find the area of the circle of this region, you can multiply it with 4, right? Because similar 4 regions you have. So multiply it with 4, you will get the area enclosed by the circle. What you have to do is you have to integrate these circles, with respect to x. If you are doing, then you do this. Fortunately, in this situation, we can integrate this also, x dy, this also we can do, and this too we can do here, because it's like symmetric, you can see. So the same region is coming. So from here to here you integrate in with respect to y, or from here to here you integrate with respect to x, right? And we know what y is, what x is for a circle. So we can do this. If it is a straight line, I want to tell you that also, because sometimes line, there are 3 types of lines. One line is parallel to x-axis, another line is parallel to y-axis, another line is inclined, right? Now if you try to integrate this line if you are integrating, you can integrate this line from one point to another point, a to b. You can integrate this line. This line's equation is going to be y equals a. So you are integrating with respect to x only. You are integrating with respect to x only, because you cannot do that with the y-axis. If you do that, there is no from point to point on the y-axis. There is only one point. That means the area with respect to x, with respect to y, that is x dy, is actually equal to 0. There is no value, right? You do not have a definition for x, right? You have only y equals a. So therefore you can integrate it with respect to x only. So when you are doing that, you will get a rectangular space, and that area will be automatically, it will come, right? Y square by 2, and ax. So you apply x equal to a to b, x from a to b. So you will get this area. This is for parallel lines. Similarly for the y-axis, x equals a it will be. So you can do that with respect to y-axis only. Here the possibility is x dy. The other possibility, this possibility is not there. Integral y dx possibility is not there for this. This is for y dx, right? This is for parallel lines. If it is inclined line, if it's an inclined line, what is that then? If it is inclined, then in that case, this is the inclined line, and this is x-axis and y-axis, x-axis, y-axis. If I have to integrate this, I can integrate it from a to b. Now integrate this line. This line is y equals fx, right? Now you have to integrate it with respect to x axis. You can do that if this is the region that is required. If this is the region that is required, then you have to integrate it with respect to y. X dy is what you have to apply for this line. Okay, so for different curves, I have told you this is the basic concept, right? With that, I end this part 3a. We will meet in part 3b. Thank you.